Welcome to our presentation on Quotebank, a corpus of quotations from a decade of news containing millions of attributed quotations. In the recent years, it has become increasingly easy to feed our daily need of information. Reading news articles on our social media or watching a 24-hour TV news channel have become mundane activities. However, misinformation and fake news have never been as prevalent as recently. This creates a need for us to understand and separate what is real from what is fake. One way of approaching this issue for us would be to look into quotations of people in news articles. Being able to answer the question, who said what, could definitely help us with answering this question from the BBC News. Did they really say that? In order to verify the veracity of the facts. Yet, answering these questions at a web scale represents a task that a single human cannot handle by himself. A large bank of attributed quotations would, however, be valuable in multiple research fields. So today, we'll present our approach at answering the question, who said what at a large scale. Our main contribution can be split in two parts. We'll first introduce Quobert, our end-to-end framework for extracting and attributing quotations that scale for large corporas. The main advantage of Quobert is that it's decently and minimally supervised, requiring very little human input. Actually, the only thing you need to feed Quobert is a single seed pattern, something very close to a regular expression that can understand the simplest form of direct quotations. We apply Quobert on a large news corpora to leverage the natural redundancy of the news, that is, different news outlets reporting on the same event, to our advantage. Applying Quobert on 163 million news articles in English, we generate and make available a corpus of 178 million unique attributed quotations that span over a decade from 2008 to 2020. But what is quotation attribution? Well, let's start with an example. Quote, Quotebank contains millions of quotations, unquote. Tim told the audience. Well, the first step in quotation attribution is to find and extract all the quotation in the article. For the sake of this example, let's only consider direct quotation between quotation marks. In this case, that would be Quotebank contains millions of quotations. The next step is to find candidate entities that may have uttered the quotation. In our case, we leverage Wikidata to find mentions and partial mentions of entities. Wikidata is a large open source knowledge base that contains, among a lot of other things, millions of entities and their aliases. In this case, we would be able to find Tim in the Wikidata database. The last step is to perform attribution, that is, matching the candidate entities to the quotation. This example is pretty easy and follows a simple rule, that is, quotation entity told. And in this case, it's pretty easy to find that the quotation was uttered by Tim. Let's take a second example that is slightly more complicated. Tim has made strong claims to Jane, a fellow student, such as, quote, Quotebank contains millions of quotations, unquote. We start again by extracting the quotation. In the case, we find the same quotation as before. The next step, we extract all the entities that we can find in Wikidata. In this case, we find two entities in this excerpt, that is Tim and Jane. Then comes the step of attribution. While here, we can start to raise some concerns. We have multiple entities to choose from. We cannot simply take the closest entity to the quotation, as it would result in an incorrect attribution. Secondly, we don't have a verb or some other syntactic clues that could help us, like we had in the first example with the verb tell. So, we need to use our human brain and require semantic understanding in order to match Tim to Quotebank. I hope that you can see that pattern matching cannot enable us to extract all the quotations. How was quotation attribution performed historically? Well, the two standard approaches of unsupervised and supervised methods were applied. Unsupervised approaches rely on rules close to regular expression to perform pattern matching. as we perform pattern matching, the quality of the attribution is very high. Yet, you would require many rules in order to account for the complexity of a language, and we have seen that some quotation cannot be attributed using rules. In order to not to have to write all those rules by hand, a model developed by Pavlo, Picardi, and West was presented in 2018 called Quootstrap that relies on bootstrapping in order to discover new rules. Well, however, the typical drawback of unsupervised approaches is that they suffer from a low recall, as you have seen that the language is pretty complex. That's where supervised models come into play, because you can make a prediction for every quotation based on its context. For example, you can output a probability distribution over the entities for any given quotation. With supervised model, you can even handle implicit mentions as our second example. The only drawback from supervised model is that they require a large and fully annotated corpus, which doesn't scale because it becomes increasingly expensive to produce. But how to deal with the drawbacks from those two usual techniques? Our approach for an attribution framework is to combine the best of those two worlds. The key idea is to use pattern-based bootstrapping in order to generate enough training data for a state-of-the-art, data-hungry, supervised transformer architecture. A key underlying fact to our approach is that quotations like Quotebank contains millions of quotations are typically reported by various news outlets in a variety of contexts. For example, let's take these four representative cases. Outlet 1 and 2 decided to represent the quotation in an easy-to-understand pattern that we can use rules to discover. The third one is coming from our example 2, and we have shown that we need semantic understanding to understand it, and it cannot be represented using rules. And in the last outlet, they may even decide to not include team directly, but rather implicitly. Maybe they have mentioned me earlier already. The first step in our attribution framework is to leverage Quootstrap, the unsupervised pattern matcher that uses bootstrapping to generate new rules. With that, we want to extract as many pairs of quotation entity as possible that we can then use as training data. To perform the bootstrapping step, we need a seed pattern. In this case, let's take quotation set S and our previous examples. Remark that you can actually take the seed in another language if your target application is not in English. Let's try to apply the seed rule to our example. We can clearly see that directly the first quotation is matched by the pattern. With that, we can then extract the quotation and team as a pair. Then, we want to find the other occurrences of the quotation and team together. We may find that example 2 and 3 would match. We can leverage our findings to generate new rules. In this case, for example, we could generate the rule quotation entity taught. This would be a good pattern because this new pattern that we extracted could be found in many cases in our dataset, so we can expect it to be of high quality. This allows us to extract a high quality bank of quotation entity pairs. Yet, the issue is that the contexts are not very diverse because we cannot create rules, as we have said, for the last two examples. That's where the last round of data expansions come into place. We want to find all the remaining occurrence of quotation entity pairs that were not covered by rules in Quootstrap. The two first examples are already covered by Quootstrap, but the third example, as we have mentioned already before, cannot be found using rules. However, as this is an implicit attribution and it contains a rich context, it is very valuable for our transformer architecture. In the last example, the correct speaker is absent. We use those cases to train the model to sometimes decide to not attribute a quotation. Indeed, the correct entity may be absent from the context or the pool of candidates because our entity extractor is not perfect, and we would rather not attribute a quotation that attribute it incorrectly. The last step, now that we have enough training data, is to fine-tune a transformer architecture with a classification head to predict the probability distribution over the candidate entities. In our case, we leverage a vanilla version of BERT to get the contextualized embeddings But you can use any transformer flavors that you like and that supports the target language of your application. We wanted to verify the quality of Quobert's annotation. To do so, we crowd-annotated 1,500 quotations and their context, split in 3 categories. The first category contains implicit and complex context that were not recognized by Quootstrap or using rules. The second category contained context where the model had to choose between 5 or more entities. And finally, we also took a random sample from our dataset in order to see how Quobert and the baselines would work on a representative set. We compare Quobert to 2 baselines, a nearest entity naive model where we attribute the quotation to the nearest entity, and to the only widely available framework that is presented by Muzni et al. In 2017 and that is based on a 2-stage sieve approach. This framework is available in the Stanford Core NLP library. And as we can see, our model outperforms every other approach in every category, be it when we want to decide to attribute a quotation to an entity or when we decide not to do so. The overall correct attribution rate of Quobert is 86.9%. The next step would be to run our model on the entire dataset to generate Quotebank. Running Quobert on 163 million English news articles allows us to generate a dataset of 178 million unique attributed quotations uttered by more than 900,000 distinct speakers. The articles themselves come from more than 377,000 unique web domains over a span of 13 years from September 2008 to April 2020. The most frequent speakers are obviously politicians like Barack Obama with more than 1 million quotations or Donald Trump with about half of it. But this dataset also covers sports, everyday events, and a lot of other topics for you to uncover. Alright, now that we have so much quotation data, what's the point of so much data? What can you use it for? Well, we think that for using Quotebank, there is 4 axes for you to explore, which can be summarized with this question: which sources reported who, said what, when? It would allow you to do data-driven analysis at scale of the public statement of hundreds of thousands of speakers. For example, some approaches could be to perform the generation of claim provenance graph for fact-checking and combating fake news, or to research the propagation and the coverage of events in the news. A lot of other applications in NLP, computational social science, or journalism can be thought of. One such example is to look in the shift in political attitude from US Senator Lindsey Graham, who became famous after going from being a Trump skeptic right before Trump's election in 2016 to a Trump psychic right after the election. In order to look at this complete reversal of his stance, we want to look at the discourse of Lindsey Graham in the public news. To do so, we take all available sources and then the quotation attributed to Lindsey Graham that are about Donald Trump. And for the time frame, we look from June 2015 onwards, when Trump announced his candidacy for president. To do so, we aggregated the embeddings of his quotation at a monthly level using BERT and then projected those embeddings using PCA. We can see that the months before the election and the months after the election are linearly separable along the principal component. To verify our claim, we also created 2 contrived groups, one of positive statements and one of negative statements, to compare with the actuals. We then projected their embeddings on the PCA plot and remarked that they landed on expected places along the principal component. While this is but one example of an already known opinion of a single politician towards a single topic, it highlights the potential of Quotebank to enable data-driven analysis of the public statements of hundreds of thousands of speakers and much beyond. Along Quotebank, the code for Quobert, our decently and minimally supervised end-to-end framework, is available under our GitHub page. We hope that you will make ample use of Quotebank and Quobert in your research. We would like to acknowledge the SIG Higher Travel Grants Program for sponsoring the participation of students like me to the conference. Quote, thank you for your attention, unquote, said Tim.